Cool. Good morning and welcome to this session. My name is Bhanu Prakash and I'm a program manager in the Big Data product group that builds Azure SD Insight, Data Lake, and other big data tools. Today I'm going to talk about how to build robust big data solution. And to me, this means two things. One is basically why you want to build a big data solution, what are the business problems you want to solve using that, and then secondly, how you want to build a robust architecture of the big data end-to-end solution. So I'll start with I'll focus more on the later side, which is the architecture, but I'll also start with the business use cases of why you want to build a robust big data solution. Because I think it's always important to understand what are the business problems you're going to solve by a big data solution. So let's get started. So we'll start with understanding what is a data lake and how it fits in your data strategy. We'll talk about architecting the Lambda solution for big data. How many of you here have heard of the Lambda architecture? Okay, quite a few, I would say 1/10. So I'll give some time to define that. And then thirdly, oftentimes what we hear from the field or customers is, hey, you have got 3 services which almost do the same thing, and which one I should use. So I will talk about the different services that are available and which one you should use in which scenario. So let's talk about the evolution of big data. So originally, big data started as a solution to solve large batch problems. So things to do like ETL, do it like overnight, do processing of petabytes of data every night, and then get the results, and then do the same thing like over a regular interval of time. But the reality is people started to use and aspired to use big data in a way as they would to any of their on-premises solutions. So more like real-time solutions, doing like sentiment analysis and so on. And then when you had batch and real-time, it evolved to doing more like predictive analytics. So that business users could not only do batch processing of the data, but also real-time processing at the same time. Use some of the tools like R or two other technologies to do predictive analytics by doing machine learning and other tools. So before going into the architecture, as I said, I wanted to start with some of the business use cases and what people are doing in real life. Let's start with some of the examples. So Virginia Tech was using this petabytes of data to basically process that data to do sequencing of genomes. And what happened was when they are doing this on premises, it used to take them 2 weeks to do one sequencing of genome. And when they moved to Azure with the bursting of SD Insight, they were able to do 20 sequences of genome per day. And not only that, with that they were able to scale their compute nodes when they wanted, when the processing requirement was huge, and scale it down or shut down the cluster, and that helped them to save costs. So if your requirement is to use 20 nodes for day 1, scale it from 10 to 20 nodes, and the next day or on Sunday you don't want to do any compute, just shut down the cluster and then restart the next day. So that helped them save a lot of money. Other companies have been using or plan to use big data more from a BI point of view. In this case, Carnegie Mellon was using big data solution to save or reduce the energy cost. A lot of the real estate things like universities, malls, strip malls, large companies like Microsoft or your companies have also been thinking about how they can use big data to reduce energy cost. So in this case, what Carnegie Mellon was able to do just by using SQL, Power BI, and SD Insight, they were able to save like 30% of the cost, and that's without even streaming or machine learning. And all of these companies, they have been thinking like if they could save even 10 or 20%, which is a significant cost savings, it would help them save a cost a lot. Let's talk about the companies that have been using big data solution to streaming. So I talked about batch, I talked about BI, and then I'm talking of the streaming part, which is more like real time. So if you go to some of the restaurants, what you'll see is on the table, there is this tablet. And you start browsing the tablets to play games or go through the menus to find appetizers or desserts and so on. And what's happening in the back end is that data that you are seeing is being streamed back to the compute engine in real time so that machine learning APIs can understand, assign a rank or score, and then send that data back to your tablet to come up with some promotional offer. So let's say you are looking at the dessert menu, you order the main course, you are looking at the dessert menu, and the kids are looking at it, it will send you a promotion offer that will say, hey, for 20 bucks, dessert for all your family or something like that. And that's all powered by the machine learning APIs. And through that, companies like Chili's, they have been able to improve the customer satisfaction. So this is one way to sort of use streaming and machine learning to improve the customer satisfaction. So what would an aspirational demo look like when you combine all the pieces, the batch, real-time, streaming, machine learning, what it would look like from an end-to-end solution? So we have a demo that I wanted to show before going into the architecture to see the possibilities that big data tools can enable. So let me just. So Woodgrove is a financial company, and I'm going to talk about two personas. One is Jeff, who is a financial advisor, and then we'll talk about his boss, Rob, who manages the portfolio of his. There are a lot of financial advisors who report to him. So in this case, Jeff will log on to the app and then see how his clients are doing, get some real-time information through news, through alerts, and so on, and then make some business decisions based on that. So Jeff is out for lunch, and then he gets an alert that Contoso earnings dip, irregularities found due to the carbon dioxide test. So he wants to know, because of this news, are there any clients that are impacted by this news? So he logs on to the app, and then in the app you see there is this real-time stocks data that is coming in through Events Hub or Kafka. And then there is this news, videos, and then the stocks. And he also sees different sectors. So since Contoso in this case is an automotive sector company, he tries to see which are all the clients that are impacted or have investments in this automotive sector. And then he sees like Ben Andrews is on the top, who has invested and who seems to have a negative impact based on the investment that he has done. So he clicks on his profile, and then he sees the CRM data about his age, his phone number, the last meeting, last call, and he starts seeing all the data, his investment, and some of the KPIs in terms of performance versus target, the churn score, the risk score. So all the things that you see on the right, the churn score and the risk score, these are based on the machine learning. And then all the things that you're seeing, these are the real-time streaming data that's coming in. And then these are the CRM data that I talked about. So he clicks on the churn score, and then this goes and opens up a Power BI report. And through this report, he wants to take and analyze what's going on. And all this BI report is being fed through a SQL database or a SQL data warehouse. And then he can see like the churn analytics, the share volume, real-time stock trend, and so on. So when he goes down into the total transactions or the average transactions, what he sees is that Ben is the guy who has had the max in terms of the total transactions that among all his clients. So things like that is a sort of an indication that Ben may be moving away from being his client because of all the news that he has seen. So he goes and then clicks on customer churn alert. And then he makes a note that he will talk to his manager and then discuss with his client to make sure he can retain Ben as a client. So he clicks OK and then goes back. And then now he sees like Ben is marked with a flag both places to make sure like he remembers whenever he logs into the app through his phone or through web app, and he makes a note to talk to him. So this was one of the personas. Let's talk about the other persona. So Rob, as I talked, is his manager. He signs in, and he gets data which is important to him, tailored to his. So he sees the streaming data, he sees the stock codes, he also sees like the top performers or bottom performers. And at the same time, he wants to make sure that the system has to be compliant. And all the alerts that he's seeing is again powered by the machine learning APIs, the machine learning algorithms that's happening in the backend. So there is something called suspicious trading. So he clicks on that. He wants to make sure like his direct reportees and the clients that he have are not doing anything illegal. He goes to the Power BI report, and so he looks at like suspicious trades, individual stocks, and so on. So on this, he sees a chart, and then let's say he selects for Michael Allen for this security stock. And then he sees like Michael has done a transaction which lot of transaction where the value is a lot which happened just before the stock like went to its peak. So that was sort of a clear indication that maybe that he had insider information, and that is the reason he did a lot of transactions. So he goes ahead, clicks on alert compliance to make sure like his compliance team investigates to make sure like the system is compliant. So he goes and then logs back. And this was sort of an example where we talked about how a system, a big data solution can be built in a way that it has everything built into the application. Like you don't have to go to different things, but everything is built into the application, business application that your users, business users are using and powers them. So let's go back to the architecture. So let's talk about how we want to build this in the right way, with the right architecture, with the right tools that will enable a solution similar to the demo that you just saw. So oftentimes when I get into call with the customers or our field, one of the questions, or I would say 3 types of questions that falls into like these 3 categories. The first one is like, hey, I'm not sure if my architecture is correct. Can you take a look? And part of the reason for that is they are not sure if they have to use event hubs, or Kafka, SQL DB, or SQL Data Warehouse, or Data Lake Analytics versus SD Insight, Stream Analytics, or Spark Streaming. And that leads to like second category of question, and I'll talk about going through all these different services and which one you should use. And then thirdly, there are situations where customer goes based on the knowledge or information they have. They start building their architecture in test dev, and just before 2 weeks before the production, they'll come back and say, hey, I built this solution, and we are going live into production in 2 or 3 weeks. Can you please take a look if my architecture is right or not? And so we'll walk through how these different questions, how do we want to answer these different questions and how it helps to sort of define what architecture we want to build. And frankly speaking, these would help also, it comes to define like the different core principles are there for building a big data architecture within Azure. So the first one is decouple the database, and we'll talk into detail about it. The second one is to build the Lambda architecture for the robust big data solution. And then the third is choosing the right tools and services. And the fourth is understand the importance of managed services, whether you want to use on the IaaS or PaaS or SaaS. So we'll talk about that. So decouple the database. Let's talk about it. So in the on-premises world, one sec. In the on-premises world, if you looked at people using Hadoop, the steps involved would be to first sort of scope the node cluster size, so whether you need 2 nodes, 10 nodes, or so on. And once you have, then you get the open source bits or bits from Hortonworks, Cloudera. And then you build it, you configure it, you have to make sure like all the services are up, running. You have to then administer it, monitor it continuously. If things go wrong, you have to make sure like the VMs and the nodes are up and running. And then you let your developer add data and then queries, user add queries to it to take meaningful information. But this, to again build it, to get the hardware and also getting it approved from your company, it would take like a couple of months or so. And once you're at this stage, if something goes wrong, you have to go back to stage 1 to estimate the size, how many nodes you need, and then do all the steps. So let's say you start with 2 nodes, and at this point, the storage and compute is in the same thing. So there is 0 CPU utilization, 0 storage consumed. And then after 6 months, you see that the storage, because the data has been continuously added, it's almost full. Compute is like 25 to 6, on an average 25% utilized. So you have compute, like there are not a lot of queries. But the storage is almost like 90% filled. So you think, OK, let me add more nodes. So you add 2 more nodes. And then storage is almost like 50 or 40% utilized. Compute is like, yeah, a little bit around the same lines. So now you are doing fine. And then you start adding more users, more queries. So on day 400, it's like compute max out. It's like 100% peak, and then 75% average. But the storage is fine. Storage is not the bottleneck. And then you think about, OK, I need to add more nodes because I can't do any more processing. So you go ahead and then double it again. And now your storage is also sparsely there. And then compute is also fine. But this was just an idea of the fact that because storage and compute are in the same thing, you can't scale them independently. You have to add both parts, even though one of them is the bottleneck. So what this means is in a typical big data pipeline, when I say decouple the database, you have to have a separate store, and you have to have a separate compute. The storage, some of the solutions we'll talk about, but what it helps in the previous example that you saw was when storage was the bottleneck, you are adding storage and compute together because they were on the same part. When compute was the bottleneck, you are adding storage and compute again together. With this sort of architecture, when storage and compute are separate, you have to scale them up or down independently. And so we'll talk about how the data is ingested through bulk ingestion and the event ingestion. And then, of course, it has to be consumed by the business users. In this case, note that the discovery and visualization, they are different. By discovery, what I mean is basically how you want to enable the business users access the data through making sure they have got the paths documented, or you're using like tools like Informatica and so on, or data catalog. And then visualization is what you enable the business users to run like interactive reports, just like the demo that we saw where Jeff and Rob went to the Power BI report and do some real-time machine, based on the machine learning information, they are able to take decisions. So visualization is like powered through Power BI or Informatica or Tableau. So let's add some of the product examples of how this would fit in. So for the bulk ingestion, we'll talk a little bit about Azure Data Factory and how it helps in moving the data. We'll spend a fair amount of time in talking about Azure Events Hub and Kafka. And then for the storage, we'll go into in depth about talking about the data lake store. And then we'll talk about the compute using different applications. So we'll talk about HD Insight. We'll talk about data lake analytics. We'll talk about streaming analytics and machine learning. And then for visualization, we'll talk about Power BI and then SQL DB and SQL Data Warehouse and how and which one you should use. So data lake store. Data lake store is generally available. So until last year, it was in public preview. I think in November, we made it generally available. It's available in a couple of regions in the US. So basically, data lake store is something that we built from ground up, used on the learnings that we had for internal storage that powers a lot of internal applications within Microsoft. There are no limits to scale. What I mean by that is you could literally store petabyte file size and millions of files in the same storage account. The throughput is good. You could store data in its native format, and I'll talk about that in a little bit. It has got all the enterprise-grade access controls, the role-based access controls. You can set up a firewall to make sure like a defined set of IPs could only access the data lake store. There is encryption at rest. And when I talk about scalability, you will see like performance difference, especially when the size of your query or size of your data is big compared to any other similar tool that does the same job. So Azure SD Insight. Azure SD Insight, how many of you here know about Azure SD Insight? Okay, a few. So Azure SD Insight is a PaaS kind of service for open source Hadoop and Spark. What I mean by that is, the example when I'm showing you have to purchase hardware and do everything, install the services and do on. In this case, what you have to do is just go into the Azure portal. You select the type of the cluster that you want, whether it's Hive, we added Spark, I think last year, Kafka is in public preview, Storm, and so on, or R server. So you select the type of the cluster, give some inputs like how many worker nodes you want, what type of VM you need, D series or A series, and so on. And within a matter of few minutes, you get your cluster up and running. And so if your needs change, you want to use it, let's say, just for batch processing, run it, and then delete it, and then recreate it when you want it. If you want to use it for real time, let it run with the right amount of nodes. If you want to scale it up, you can scale it, and if your needs change, you can scale it down just by going to the slider and then writing the right number of nodes. It has support for Visual Studio, IntelliJ, and all sort of your existing development environment. We are constantly evolving HD Insight. It has been generally available for a couple of years, and so we recently shipped Secure Hadoop. So it has got all the enterprise features like monitoring. It also supports Ranger. It has Active Directory authentication integration. So you could have the right set of security built into the Azure SD Insight cluster. And the fact that you don't have to pay for the hardware, you are only paying for the compute, and then for the storage, you are paying separately for whether you are using Azure Blob Storage or Data Lake. You can save your total cost of the ownership because you will be paying only for the time of the compute that you are using. If you want to have just 2 nodes, you are just paying for 2 nodes and not 10 or the number of nodes that you started from. So I talked about the fact that we also added R server and which means compared to the open source R, it has like 1000x more data capacity and 50x more performant compared to open source R. And Kafka is in public preview, so we'll be going into GA soon up with Kafka. And it has support for the right set of BI tools that you need. So data lake analytics. So I was talking about SD Insight, which is more of a PaaS service, as in you don't have to take care of the VM, Node OS patching, and so on. Azure Data Lake Analytics is something more of a SaaS, I would say, or more like a job service. So in this case, you don't have to even spin up a cluster. What you have to do is literally go to the Azure portal or go through Visual Studio, and then you write up your query using SQL-like with a mashup of C#. And then you deploy that query, and then we take care of running that query on a shared yarn cluster, which is managed. And then based on how much parallelism you want, you choose that level of parallelism, whether like 4 vertices, 10 vertices. That will define how faster your query will be executed. And then you pay for the time the query runs into the level of parallelism that you have chosen. The good thing about both Data Lake Analytics as well as Azure SD Insight is we provide, for Azure SD Insight, we provide like best SLA in the industry, which means it's not only your VM instances, but the end-to-end cluster. We are making sure that it is up and running 99.9%. So if your VM goes down or if service goes down, we make sure like it's up and running, and we have an on-call team to help support that. In fact, like if you are familiar with Hadoop, there is something called name node. In traditional Hadoop, you have to like go, the default is like one node. But on the SD Insight, we have like made it highly available. So if one goes down, it like fails over to the other one. And so talking about the Data Lake Analytics, it has the role-based access control. It federates across the different data sources. So what I mean by that is, when you run your query in Data Lake Analytics, you don't have to copy data from database to data lake storage or data warehouse to data lake storage or somewhere. You run the query on the Data Lake Analytics cluster, and then we take care of like integrating across different sources, augmenting the data, and there isn't any duplicate copies of data in that case that you would want to do. So let's talk about some of the usage scenario here. So before like big data came in, and some of you might be familiar, like we have been one of the scenarios that Hadoop and other tools like SD Insight or ADLA handles is doing ETL. So what I've seen, some of the customers, they are using ETL at the sources where data come in before feeding that data to SQL data warehouse. My recommendation would be to stop doing that, because you could use the parallelism offered by SD Insight and Data Lake Analytics to do ETL right there instead of doing it on the sources and then using data warehouse and database to do the ETL. Because let's say if you are using Hadoop to, let's say, run your job on 10 nodes or 20 nodes or 100 nodes, you could do the same power and use the power of distributed and parallel computing to do your ETL jobs. And that's why what I mean by that is you load your data into Data Lake Store or blob storage, let SD Insight or Data Lake Analytics do the ETL, and then you store it back to Data Lake Store or other storage to do machine learning and other processing on it. But you don't have to spend your existing data warehouse or other tools to do that for you. So let me tell you like what it would mean if you were to move from on-premises to Azure and what a simple architecture might look like. So here you load the data into Azure Data Lake Store, and then you have 2 compute nodes. Let's say for you are added 2 clusters, SD Insight clusters, or you are doing your processing through ADLA, Azure Data Lake Analytics, and sorry, and then through ADF you are pushing that data to SQL DB, which kind of drives the Power BI, which is the source of the data for Power BI. Now what happens is your storage needs scale. So your data grows and data lake store grows. And at the same time, your compute needs also grows. So Azure Data Lake Analytics and SD Insight also grows. And then one of the things you will see is in the past, you are using SQL database, and now you are using SQL data warehouse. And I'll talk about which one to use or which one, but SQL data warehouse, when your storage needs grow more than like 1 terabyte and all, you move to like SQL data warehouse. And the good thing about this architecture is each pieces of the puzzle should be able to change or swap with other equivalent service that supports more scalable or other scenarios without impacting the rest of the system. So in this case, you are able to move from SQL DB to SQL data warehouse, and Power BI, which was working with SQL DB, now works with SQL data warehouse without any issue. The same for data lake store. It was feeding data to SQL DB, and now it's feeding data to SQL data warehouse, and it works fine. And then you added more nodes. So you are able to scale your compute independently. You are able to scale your storage independently. You are able to scale your presentation layer, which is SQL DB to SQL data warehouse. And that is like the rule number one of building a robust solution. That is scale your components without impacting the rest of the system. And then in the very future, we will be adding support for Polybase, and what it will allow is to parallelize the feeding of data to data warehouse. That will make sure it goes to data warehouse much faster than it would with Azure Data Factory. And that way, your business users don't have to click and then wait for 5 minutes or 2 minutes. It will be all real time and much faster. So Lambda architecture, I talked about the fact that we'll talk about this. It was described by a guy, I think 5 or 6 years back. What it tells is you load your data, you do batch processing, and then you do real-time processing in the same environment. So you are getting the best of both worlds in the same environment. You don't have to do batch there and then real-time here. You are all doing it in the same end-to-end solution. So how do we go about building a architecture, Lambda architecture? So generally speaking, it's in 4 layers. You start with the data consumption, which is the bulk ingestion or the event ingestion. And then you go through preparation and the analyze phase, which is more like transformation, extraction, and all that. So it has speed layer and it has batch layer. Both are equally important. This is sort of the compute part of it, compute as well as the storage, which are all separated. In the batch, what I was saying in the past was like using your ADLA or SD Insight to do batch processing. This is what it was refers to the batch layer, where you use SD Insight and then do processing of your queries. And let's say it takes 1 hour to do the queries. You can just scale up your nodes and do the same query in like 15 minutes. And when you create it to an on-premises world, it would be like a real time. But in the Azure world or in the cloud world, it would be, I would say, a real-ish time. And then on the top, which is the speed layer, when you talk about IoT scenarios where the data is coming at a very high rate, you add the speed layer with some of the tools that will help process and store that data at that rate. And you combine both speed and batch layer, just like the example or the demo that we saw. And then the right is the presentation, which is how you consume the data through Power BI, Tableau, and other tools, and make sure like tools like SQL Data Warehouse is sort of the backend data for that presentation. So let's talk about some of the concepts of the requirements for the Lambda architecture. Scalability. We talked about this sort of through different examples. So we talked about the fact that you can scale your HD Insight nodes from 10 node to 20 node just by going through a slider, by doing manual resize, and so on. Same, you are able to do it for your storage. or you are able to do it for Azure Data Lake Analytics, but just by going to Visual Studio, changing the slider or the portal, adding more number of vertices, lowering the number of vertices, and so on. And so basically, each pieces or each component should be able to scale up and scale down, and that helps you to save and manage cost. Resiliency, which is basically the ability for something to come back if something breaks. And both Hadoop and ADLA and other components have resiliency built into it. For SD Insight, we say, especially as compared to Hadoop, it has more resiliency built in. The fact that we have added the name node, which is highly available. There is automatic failover that happens. The VM instances will be up and running 99.9%. That's not just for a VM, but whole end-to-end cluster. And so it is very important to make sure you have a resilient service that supports this architecture. We'll talk about the low latency, the fact that, especially in case of Kafka, the data has to come at a very fast rate, and the system has to support low latency for that. Extensible by that handshake, what I mean is the fact that you are able to swap database with a data warehouse, or you are able to change from like HDI to ADLA and so on. So the system should be able to swap the right set of services or the tools for the purposes that you need without affecting the end-to-end scenario. And then, of course, it has to be maintainable in the sense like it has to have the ability to upgrade or to apply the patches to the VMs, or and then you have to make sure that you are choosing the right set of tools to do that. For example, let's say you have the option to run Hadoop or like an IS manner. So you go and then use the IS VMs and then install Hadoop on that. And then the other option is you directly go ahead and use SD Insight service. So in SD Insight, the OS patching and all, making sure like it's available 99.9%, the SLA and all that is already available. But in the IS, you have to do some sort of things to make sure it gets to that level. And versus if you are going more in the on-premises, you have to do literally everything. So you have to make sure what level of manageability you need and how would you want to maintain it. So the right set of tools needs to be there. So let's start with the first part, which is data consumption. And so we talked about the fact that it's basically the first layer where the data is being injected into the system. So let's talk about the event ingestion. So you have data at a very high rate that's coming through business apps or web apps or your custom apps, devices, sensors. A lot of IoT scenarios are being enabled, and it's like very hot these days. So the data is basically coming at a very high rate, right? And then so here you have two major options. One is Azure Event Hubs, and it is a very simple to use service that allows you for injecting or getting the events from different sources. And then Kafka, which is the open source Kafka, which is something that you can manage as a PaaS service. And the fact that I said it's in public preview, so you can use either of these services to inject the data. And then for processing or doing analytics on that, there are three options. The first is streaming analytics, and we'll talk about all these, which is again sort of a job service or SaaS service through which you can do stream processing of the data, which comes at a very high rate. And then you have open source Storm, and then Spark streaming, which we'll talk about. And then once the data is processed, it goes to the Power BI for consumption. And then you also want to make sure that the data lands into ADLS for future machine learning or other processing. So let's talk about the ingestion technology. So as I said, there are two options, Kafka and Event Hubs. You'll come across like different tables as we compare and contrast the service, and I have added in bold like that shows like the differentiating factor. In this case, the reason I have made Azure Event Hubs as bold compared to Kafka is the fact that in Event Hub, you don't have to like manage a cluster as a PaaS service. Like you don't have to go ahead and create a cluster and so on. In Kafka, you have to do that, but as a managed service. So It's a very simple to use service, Azure Events Hub. You're looking at throughput of 20 throughput units. The cost is low. You have to pay for the usage of that streams. And then I think the record size is like 256K. Both of these are sort of almost similar in the fact that they could process like millions of events per second. But if you are looking for something with a very highly scalable needs that could process multi-billions of events per day, especially like connected car scenarios, you go with Kafka. But if you are looking to just start with, you start with Events Hub, which is pretty simple. But when you need change and you're looking for more processing of events at a larger scale, then you would need to use, you should think about using Kafka. So we talked about the ingestion. Let's talk about the other components. So the streaming analytics. So we talked about the fact that it's getting injected through Event Hub and Kafka. Now it goes to like stream processing. So there are three options in this: Stream Analytics, Storm, and Spark Streaming. Stream Analytics, like the ADLA analytics, is where ADLA is more like, I would say, batch thing. This is more like real-time streaming. So you do processing using like SaaS-based sort of service. So it's very simple and easy to use. You could use like windowing aggregation from out of the box. And you don't have to like have a cluster up and running as in the case of Storm and Spark. If you are going to just start like using this, any of the stream processing, start with ASA, which is pretty simple to use, and you can always move to Spark, Streaming, and Storm. One of the things that I would point out in the case of Spark and Storm is the fact that these are open source technologies. So the ecosystem is pretty huge. And what I mean by that is if you have any questions or anything like that, you could basically find the answers on the Stack Overflow on the same day versus asking the questions, and it takes a while to get the answer. And then Spark and Storm, I would also say it's more, you would think about using it from like highly scalable scenarios. You can manage the cost and all that. But from an ease of use perspective, from a robustness perspective, you should start with something like Stream Analytics. So how does Event Hub and streaming sort of handle the scalability scenarios? So what Event Hub does is when the events are coming, it partitions into different partition ID. And when the egress, Stream Analytics consumes it, you can partition it by partition ID. And that way, instead of running one single query, you are essentially running multiple queries. And that way, the speed of that processing increases. What this would mean is you would want to use, let's say, machine learning and streaming at the same time, which is good, just like the example where we saw like streaming is happening and then machine learning and so on. But one of the caveats or the downside is like the performance might go down because of the fact that now your data is being streamed, processed by Stream Analytics, and before it goes to the data lake store or the application, now you are using ML APIs to assign a rank or a score, and then ML has to process it, so it would decrease the speed of the rate at which the events is being injected to data lake or the application by 2 or 3 times. And the recommendation there is like if you really want to use it, then use the fact that you could partition it by partition ID and then have multiple queries. Or the other option is like you let it go through the Azure Data Lake Store and then do the machine learning in a batched manner and then let it feed into the application. So let's talk about the data store. So Data Lake Store, we sort of touched base on this in the fact that there are no limits to scale. You can have petabyte file size, millions of files in the same storage account. It can be there for as long as you want, right set of securities built into it, and then seamlessly scale from like KBs to petabytes. So some of the technical requirements that were chosen while designing Data Lake Store, as I said, it was built in from some of the learnings that we had in-house, was the fact that security, it has the right level of enterprise security built into it. So the fact that it prevents unauthorized access, make sure like the right sort of IPs have access to it. It has file and folder level access. It's highly scalable, and it supports both like real-time, batch, machine learning. It's like the source for all these different types of processing data that you would need. It supports low latency, and reliability is built into this. So I talked about the fact that we'll talk about the data types that can be stored in data lakes. So here is a sort of perspective on that. So when you talk about big data, you have to store, let the data to come as it is coming from different sources. You don't want to like change the structure and all that, because you want to have all data that comes in any format that's there. So you start with the unstructured. So you're storing the logs, you're storing the pictures, and all that. It also has support for semi-structure, so basically JSON, XML, Avro, and different schema things. And then structures, basically CSV and other structured format it supports. So when you are using Hive, one of the recommendations there is to save the data in a columnar format. One of the reasons I say is when you are talking about big data, the tables are so wide. If you are using the row-based format, you would have to scan the whole row. And that way, because you are scanning the whole row, even if you are doing like select column A, column B, or so on, because of the fact that scanning such a wide row, it takes a lot of time. So imagine if you have to scan like so many rows versus just scanning the 2 columns that you are interested in. So that's why the recommendation is to save the data in a columnar format. The downside is definitely you'll have to convert it into that format. But yeah, from a query perspective, it's pretty fast if you have that. And there are 2 formats in that available. One is the ORC file format that Microsoft built in conjunction with Hortonworks and open source community. It is best for Hive. It allows all the ACID properties, insert, update, delete. There is also the ParQ format that you could use for mixed Hive and Spark workloads. So let's talk about choosing between Azure Data Lake Store and blob storage. So Azure Data Lake Store, one of the things is it is not available in all the regions. So if you are someone in, let's say, Europe or Asia Pacific, the option available is to use Azure Blob Storage. And if you want to start with in the US, there are some of the regions which have Azure Data Lake Store. The thing is, both of them are generally available. But if we have like hundreds of customers who are using blob storage, and so if you are looking for something like petabyte file size and petabyte size of file and that many number of files, you could have like multiple blob storage accounts to deal with that. And the good thing is like compute tools like HD Insight or Azure Data Lake Analytics, the performance does not impact even if you have like multiple storage accounts. So you have like multiple storage accounts if your scalability needs are that high, but not you can go ahead with basically with 1 or 2 accounts that would serve your purpose. Other thing to talk about here is the fact that for Data Lake Store, this is the storage that we expect in the future most of the customers to be in. Like today, most of the customers are using blob storage. But we expect like over a period of time to move them to Azure Data Lake Store because of all the scalability benefits and all. Blob will have some of the bandwidth issues and so on, but at the same time, if you are using like multiple storage accounts, the performance from compute part of perspective would not suffer. So oftentimes, we talk with customers like how we want to store data for enterprise robustness. And one of the recommendations is that you store the data by organizational folder structure or application folder structure. And so one of the questions that customers ask is, hey, I'm using this Azure Data Lake Store account, and how I have to have multiple business units that want to store data, my HR, e-commerce, and finance department. How do I go about billing them separately? And I don't have a good answer to that other than telling like, hey, go ahead and use different storage accounts. And in that way, you have the right set of making sure different accounts, like HR has its own storage account, e-commerce has its own storage account, so you don't have to like have different ACLs and all set. But at the same time, you are able to build them separately. And the fact that I talked about, it does not impact the performance, no matter how many number of storage accounts you have, you would be fine with that approach. The other thing is, like, of course, you have different folder structures for applications and business units and so on. You want to make sure like the data is at the granular level of access is partitioned based on the year, the month, and the time, and what level of partition do you want to go up to. And the prime reason for that is when you are running your queries like Hive, you only scan the files and the folders that you are really interested in versus scanning the whole thing. So that helps to sort of also have the right structure for the data, at the same time helps in performance. So other thing I talked about in the presentation part, the fact that there is this data discovery. For business users who are not so tech savvy and want to have like access to the right set of data, always make sure like the paths are documented correctly. Like I've seen examples where customers have used like acronyms or crazy names, and if there are new employees in the company and who are not used to that acronyms, they'll find a hard time, and this is what we call like dark data, that data is not being used. So you want to make sure, even though you have option to use tools like Informatica, data discovery and all, data catalog and all, but you want to make sure the smart way of doing is to make sure it's properly documented. Retrofitting after the fact is difficult. So when I'm talking about making sure you have the right set of structures for files, folders, and so on, you want to build it right the first time. If you don't do it the first time, you can do it later as well, but you have to have like give enough time, and it is a cost for you. So you want to make sure it's correct the first time. So big data storage for enterprises. So you want to make sure like you have the right level of isolation for the data for the different needs. For example, you have to have isolated source for the data which is raw. So all the raw data that comes in, there are no write permissions given to developers or business users or so on. It is just a raw data for the data to come in from different sources. Then you have the staging where it's copied to a staging environment where developers and test, they are using it for test dev environment. And once they vet that data, it is vetted and trusted, it goes for in production in the trusted area, so where the data is only used for production purposes. And then you have a sandbox environment where you have the data which is copied to the sandbox environment for like data scientists and business users. So they are doing like hit and trial in one and different ways to create the right sort of BI use cases. And once they find that 1 out of the 100 thing, they move it back to the staging. So it could be pushed to the trusted or vetted region to be able to run in the production environment. So these are some of the access characteristics based on these are different classification of data like hot, warm, cold between different characteristics. The reason I wanted to show it was because note that it's not just volume or item size or one of these that defines whether data is hot, cold, or cold. It may be that it takes a long time to get the data and you are fine, and that's like cold data. So it's also the volume, the size, the latency, and different factors that helps to sort of categorize the data. And then what I've done is I have put those different characteristics on a Venn diagram. And the reason for doing it, you want to make sure like you're using the right storage based on the right characteristics that you need. You don't want to, just because of the fact that you have a blob storage account, you are putting all the data into the same. See what the scenario is and put the data in the right storage. That may mean like you have multiple things, but also means like you are using it to build the right robust solution that will serve for the right reason as the cheapest cost. So let's say in this case, if you are looking for something, let's say high in structure, you would go with like SQL DB or SQL Data Warehouse. But if you are looking for something very low latency, then you would think about using cache or NoSQL database. And if you are looking for something like cold data and low in structure, you will start with things like SDFS or ADL, Azure Data Lake Store. So what this means is like to categorize this a little further in terms of tools. If you are looking for like structured and relational database, start with the data warehouse. For complex event processing, you are using the stream analytics and all that we'll talk soon. And then for non-relational, you are using the NoSQL data. And then data warehouse, so let's say if your size is, data need size is like less than 1 TB, you are using SQL DB. And if it is, you are using it for a highly scalable scenario, you want to use like data warehouse. And then we talked about this, so I don't want to go into again, but one of the things I want to point out with Spark streaming, you are basically using it for like the fact that it has very low latency. And if you are already using Spark, it's like a one-in-all solution. And I'll go a little bit deep into it in the next 15 minutes. So this is something from a processing point of view, like different tools. So if you are looking for high SQL compatibility, it's SQL Data Warehouse versus like a high query latency, it would be like MapReduce in case of SD Insight, or a low query latency, it will be like SD Insight with Spark. So in terms of the big data pipelines, one of the things I would tell is customers always go and think about, hey, let me build up this 40-node cluster, and I would use it for like ETL, and the ETL processing will run overnight for 8 hours. And then in the daytime, I would use that same cluster for doing user processing. And so they come back and say, hey, I'm looking for this use case. What is the right number of nodes that I would use for these scenarios? And the right answer is, why just one cluster? Why do you want to spend like 40-node cluster for 2 different scenarios when you could solve the same purpose by using 2 different cluster types? And what I mean by that is the fact that your ETL will be done with 40 nodes. You are literally using that same 40 nodes for the rest of the day. And remember, like, even though the fact that the compute nodes are running, you are not doing any processing, you are paying for that. So why you want to use that 40-node cluster, even though the fact that for the user queries, you may end up using only 4 nodes or 8 nodes for the rest of the day. So the recommendation in that case would be like use 40 nodes for for ETL during the night, like run it for 8 hours for the time that you use, shut it down. And then for user queries, you just have 8 nodes that you want to use it. The fact is when you shut down the 40-node cluster, you are basically not paying for it, and then have the 8 nodes just for the user queries for the period that you want to use it for. And in that way, you are paying only for the usage that you are consuming in different forms. The good thing is both can access to the same data. So it's not like for ETL, the 40-node cluster, you have to have like this data, and then for the user query, you have to have this data. They can all access the same data. And in that way, it could help serve both the scenarios. So now we talked about all the different things. Let's talk about the interaction, like how the business users will consume that data. So it's already 2017, and one of the predictions from Gartner was that by 2017, a lot of the users will like to use the interactive layer using a self-service tool and so on. And so you would already see it happening. There are 2 options for that, SQL database and SQL data warehouse that would serve as a backend data for Power BI. What I mean by that is when you are looking at using these 2 options, SQL DB, as I said, it's more for something we are looking for data less than 1 terabyte. For SQL data warehouse, it has sort of the properties that you saw for SD Insight or ADLA compute engines. The fact that you can scale it up, scale it down, you can pause in seconds. You can scale up the storage and the compute independently. And all these characteristics are part of the SQL data warehouse. So you could run like T-SQL queries that you're already familiar with, and the fact that it has integration with Polybase, and the one that will be coming for ADLS in the near future will make it even yet more powerful. So it's basically running SQL on SQL, that is the backend being SQL data warehouse, and then you're running SQL on top of it. So let's talk about data lake and data warehouse. So some of the things that you might be thinking is, hey, so I heard about data lake, I heard about data lake, data warehouse. Now, which one I should use? And the reality is, if you go back to that base architecture, base Lambda architecture, where you saw presentation and then you saw like batch and speed layer, you can use it like complementary. Data lake is like complementary to data warehouse. When I say that is, it goes back to the things that I discussed in the past, where you want to use the parallel processing offered by tools like ADLA or SD Insight to do the ETLs. And you don't want to use data warehouse for doing all that ETL. The data warehouse just serves as a data for your presentation layer. So it does not, you don't want to scale it to do ETL jobs. You want to scale it based on the number of users you want to support for interactivity. Because data lake is there to serve the data, which is the raw data, or the fact that you have to do ETL using the data in the data lake store. You can put it back into that. And once everything is structured, you then pass it back to the data warehouse. And again, I repeat with that, it might mean like having multiple tools, but it just means building a robust architecture in the cheapest possible way. So we talked about this on the data lake, using data lake and the right set of compute tools like SD Insight or DDLA. You are ingesting, you are cleaning the data, cataloging, you are doing like machine learning and all that, and then you are pushing it to data warehouse or SQL DB to do structure analysis, serving it as a backend data for Power BI or Tableau, and then doing quick aggregations and so on. So the fact that Polybase support will be there, it would mean like the data is being injected at a very powerful rate by using parallelism. And you could use it to do queries for both sides, where the data is one on Hadoop and then on the data warehouse, so it integrates very in a nice manner. So we did not talk a lot about Spark, so let's use this time to go into details. It's like the newest, let's say, darlings to the big data world, and it has the promise of having everything in the same environment. So it has Spark SQL, it has support for Spark streaming, it has machine learning libraries, it has GraphX, and the thing is, it is very interactive. It's highly interactive with all-in-one tools. So we'll talk about some of the, like how it compares to other tools. It is available in Azure as a Spark cluster, so you have to manage it as a PaaS service on SD Insight. So just like you go and create a cluster, there's a cluster type Spark which is supported on Linux. I think the latest is 2.0.1, which is much more faster than 1.6 with a lot of bug fixes. It has the same SLA offers that you would have for any other SD Insight cluster. And so it is 100% open source, taken from Apache, and we are using the Hortonworks data platform bits for Spark, just like other SD Insight cluster types. You get the 99% SLA guarantees. It has got the right set of certifications to make sure like the cluster is compliant and all that you don't have to do other way. It has a lot of community support. Being it open source, you would be seeing like development happening in this at a very fast rate. All because of the fact that it has the promise of doing everything in the same environment. So why would you not try to take advantage of that? So it has support for even Scala. We have the Jupyter Notebook support and Zeppelin. And for the development environment, it has the support for IntelliJ and Eclipse, and you could do it through the programming languages like Scala, Python, and so on. So I talked about this. One of the things you want to consider is when you want to like contrast it with other services. Let's say Spark SQL. Like the fact that you have everything available, and if it works for scenarios, that's fine. I would consider it like related to like SQL Server on premises. Like when you had the license, you want to use it for SSIS or analysis service or SQL database, and it works for you, go ahead and use that. And the same thing applies here as well. But the thing to consider here is like it may not be as robust as some of the general purpose built solutions. So let's say you talk about Spark SQL. SQL in this case is not like the first class citizen in Spark compared to compared to ADLA are high because when those were built, they were built with little bit more SQL in mind compared to Spark SQL. But again, being in open source, things are development are happening in it. Spark streaming, when you compare it with like Stream Analytics, it does not have the same set of robustness as compared to Azure Stream Analytics when you think it from a ease of point of views. And then when you talk about machine learning, it may not offer the same level of parallelism as you would see in the open source R, which is again available on SD Insight. So you want to make sure like you want to use like some general purpose tools or whether this thing works fine because of the fact that you are using the same set of environment. The good thing about this is, as I talked about, interactivity, especially on small data sets, it's highly, highly interactive. It will feel like almost things are happening in real time. For large data sets, you'd want to have, because of the fact that it uses like in-memory computing, you need to have like SSD caching and so on. And then going back to the old schools, the fact that machine learning uses sampling and so on, it has like some training data sets and so there is a inbuilt sampling that is supported out of the box, so you can use it, especially if you are like having like perf issues because of the large data sets, and that can help combat those perf issues. So what does it look like putting it all together? You have the data coming in from your on-premises world or different places, and then it goes into like Azure Data Lake Store or the Blob Store. And then you do like compute using HD Insight or Azure Data Lake Analytics. And then on top of that, you are doing machine learning, which then feeds to the published side, which is the Azure SQL database or SQL data warehouse. And then you use it to feed the data for Power BI, so business users or data analysts could use it for the meaningful information that they want to use for. Let's add more complexity to it, and this is sort of the Lambda architecture that we talked about initially when we were talking about the ingestion layer, the speed layer, the batch layer, and the presentation. So right now you have not just the batch events or the data that's coming in, you also have the streaming events that are coming through Event Hub or Kafka. And then all your data is going to either Data Lake Store or Azure Blob Storage through the different tools that we talked about, ADF or Event Hub or Kafka. And then you are doing things like compute using SD Insight, or you are doing compute using ADLA, and that is like batch processing. On top of that, you are doing machine learning, and then you are going to the streaming layer where the data is coming at a high throughput rate for IoT or other scenarios. You are running tools like Stream Analytics, Spark Streaming, Storm to do analysis on that real-time data, and then you are adding on top of that machine learning and then feeding the data back to Azure Data Lake Store so that you could do some batch processing on that same data. And through all these different sources, the data is going to Azure SQL or Azure SQL database, and then which you would use as a backend data for Power BI or Tableau reports for the business users to make like meaningful decisions from it. So what does it mean from the manageability perspective? So this is some of the last fourth part that I was talking about from a manageability perspective. You would have seen this chart in a lot of the conferences. But one of the things that I wanted to point out, since we're talking about building a robust big data solution, is you want to be all towards the greener side, towards the right side, than towards the left. So let's take example of SD Insight. It would form as a platform of service versus ADLA, which will be more like a software service or in between, and versus Hadoop on-premises, which is like the first all blue. So in the first case, like Hadoop on-premises, you have to make sure you have to buy the hardware, you have to install the Hadoop, you have to manage it, administer it, and do the all things. Versus if you are using SD Insight, all the things till like runtime is all taken care by SD Insight. The bits will be there on the VMs. You just have to click number of nodes, the type of cluster, and then click, and then It will start the cluster in few minutes, and you don't have to worry about the OS patching and all that. So everything is taken care. But you have to worry about the data and the application for which you are using it. Versus Azure Data Lake Analytics, where I would say it falls more in between PaaS and SaaS or towards SaaS, where you don't have to even manage a cluster. You are just responsible for running the query, and ADLA runs it for you on the back end. And then the last I want to point out is by giving it thought in the last one of the examples, is just like the demo that we saw. NEC is one of the retail stores. What it has is the video sensors in its stores. So as customers walk into the store, through the video sensor, that data is captured, and through machine learning APIs, it will identify the person as male, female, the number of people in the room, and all that. And so it will collect some of the demographic data, and based on that, it will run promotions in the store. So if you're like 50 people or 20 people in this age group, and male versus female, and this is the right sort of promotion I want to run, all happens in the backend through the compute and the machine learning, and it presents that thing. That promotion is run in the store, similar to some of the Chili's examples that I talked about. So how does it all fit in? Goes to the architecture that we talked in the beginning. Your event is being injected, and then you have the bulk ingestion. Data goes into data lake store. You have different options for compute, machine learning, ADLA, SD Insight. And then for visualization, you are using SQL DB or Power BI, and then you have to make sure like the data does not become a dark data and has the right paths. So we talked about the data lake. We talked about the Lambda solution and how you want to architect using the concepts that it defines. We talked about some of the services that are sort of similar, but you also want to make sure like which service you want to use. Here are some of the IT pro resources, some of the general things which is very generic. With that, I have a minute for any question, and I wanted to thank you and appreciate you for coming to listen to this talk.